Tonight we are going to cover vectors. Yeah. Vectors are extremely important. I use them on a daily basis in engineering. All right. Now, vectors is a term that covers a lot of things. What we need to be understanding of is vectors contain, or vectors are a way to describe something, okay? And its vectors contain both a size and direction. Okay. What they allow us to do more easily, right? They allow us to work out sizes in 3D shapes. All right, that's what we're going to be using it for. All right, they allow us to do quite a lot of things, but they allow us to work out sizes in 3D shapes. Now, the most difficult part of vectors is just picturing what the question's actually telling you, bizarrely enough. All right, and how it's explained and how it's written. All right. So vectors described in component form usually. All right, and this term component form will come up a couple of times, okay? So there's a couple of ways they can ask vector questions. They'll look for component form quite often. Okay, so we'll have the terminology AB, all right, equals the component form X, Y. That's your vector form. That's telling me how far and in what direction I'm going. All right, so I'm going from position A to position B. All right, so A and B are just letters telling me which point to which point I'm going to. All right, so we'll use multiple different letters there. So we use C, D, E, F, whatever it is, G, H, A, C. Okay, it's your start point and your finish point. So it's just describing 2 points. That form is your component form. The X and Y that's describing is the 2D visual of the exact same axis that we are using in graphs. Okay, so the x-axis, horizontal axis, and the y-axis being the vertical axis, that's essentially what they're telling you. Okay, we'll see that in coordinate form and work it out into vector form. Okay, so that describes direction, okay, along the x and y axes, and the size, okay, because they'll be in numerical form. Okay, so that AB, that above that is a wee arrow. Okay, just in case it's not there. If I had AB, the vector, and I wrote it out numerical form 3, 4, what that's telling me it's my movement, okay, whatever motion I'm sort of indicating is moving along my X plane, my X axis. 3 units, okay, so 3 centimeters or 3 whatever. Okay, so 3 moves along the X axis and 4 moves along the Y axis. Okay, so if I'm just drawing out like we usually do, the Y axis and the vertical, for our origin, we've got the X axis. That vector is just a line somewhere in that, okay, somewhere in space, doesn't tell me exactly where. It's going along the X axis by 3. It's not really to scale there. It's going up the Y axis by 4. Okay, now that's also telling me the direction of each of those because they're positive. Okay, but we'll come back to that. That 3 being positive tells me the sort of direction I'm going along the X-axis. The 4 tells me the direction I'm going up the Y-axis. Okay. What other examples? We'll be asked to sketch vectors, but worthwhile being aware. I've got a vector like so. So it's going to show N. Right. I would describe that and put it in component form. For the order of the letters tells me the direction I'm going. So I'm going from M to N. So I'm going in that direction. So I'm going along +5 on the X-axis. But I'm going down the Y-axis. Okay, so I'm going down -4. Okay. If I do it slightly differently. You can see that direction matters when I'm describing the component form. So this time I'm going to describe PQ. All right, PQ. It's my start. My finish. Okay. There's my direction. Going in that way. Okay. If I'm going 5 positions and up 3. Okay. That's going to be slightly different. We're going to go -5 on the X and +3 on the Y. So this is where size and direction becomes really important. Okay, does everyone see the difference in those two? So the start and the finish describes the path that it's taken. Okay, the direction of the path that it's taken. We can add vectors. Okay. When you add vectors, you're putting two lengths together essentially, but they must be added. Nose to tail. Okay, and I'll explain what that means. Okay, needs to form a path. By adding multiple vectors together, you're going to work out something called the resultant. What the resultant is the shortest path between 2 points. All right, the shortest way from getting from start to finish. Okay, an example people like to use. I know where Glasgow is, and I know where Edinburgh is. To get to Edinburgh from Glasgow, I could go up to Stirling. All right. Then up to Perth, down to Falkirk, and then to Edinburgh. All right. Now that's a bunch of different vectors I'm adding together. All right. But what the resultant is, what I'm looking to achieve, or looking to understand, is the shortest distance. The shortest distance, Glasgow to Edinburgh, would be that. All right. In that direction. All right. So that's my journey. That's my path. That can be my path. All right. But my vector sorry, the resultant. The shortest distance from Glasgow to Edinburgh takes all them into account, but takes me in a straight line. Now, this point, we'll just note the vectors are written in two ways. All right, AB or two letters like that, indicating a vector from point A, point B. Okay. But we could also write it as a single term with a wee line underneath it. Okay, sometimes in the exams, it's not always underlined. Okay, but when writing it, always underline it. For those type of vectors, when we're using that, we don't necessarily have to know where A and B is. Okay, this just describes a vector. You don't necessarily know where the start and end is. Okay, it can always be applied in multiple locations. You could apply it to multiple different lengths. All right. It just describes how far, essentially how far along the x-axis and how far along the y-axis. But that doesn't necessarily mean that vector has to start at a specific point. It can start anywhere and end anywhere in your specific frame of reference. All right, so you might see it sketched out, okay, with a start and end point. Or you might see it just with a wee underline, and that's again another way you can add vectors together. Okay. Let's look at an example of addition. Vector A by 4, B into sketch. So we're adding the two vectors together, so we want to sketch A plus B. Now, you won't get asked to sketch this, so this is just representative, all right? You won't get asked. All right, I'm doing this so you can visualize it a wee bit better. All right. So vector A, you don't have to know where it starts necessarily on a piece of graph paper. All right, there's no real fixed start point. But what that explains is something that's going along the x-axis horizontally by 5 and up 4. Alright, so that's a sketch with vector A. Plus B, okay, what I meant by nose to tail in the last wee bit is that's the tail of the vector at the end there, and that's the nose. So where would the vector finishes, that's the nose of that vector. So we're starting vector B where vector A finishes. Alright, and I'm adding that on. The vector B tells me 7 and 2. Oh, I was wondering why that was wrong. That's a negative 2 up there. Okay, I made that negative 2. Vector B is negative 2. Vector B goes along horizontally by 7, but down negative 2. Okay, so sort of sits like that. Alright. So again, it's got no really fixed point in space. It's all just sort of relative terms. Okay, but that is B. Wow, what is going on there? In the direction, be like that. Okay. So it tells me what it's doing horizontally and it tells me what it's doing vertically. A is going up vertically from start to finish. B is going down vertically from start to finish. Now my resultant, my A plus B, shortest route between them is that. Added two vectors together. Now, what's a really common question, so you won't get asked to sketch that, that's just for your visualization. Be express A plus B in component form. Remember, component forms when we've got the X value and the Y value in sort of column. Now to add vectors together, we're literally just adding the X values together and adding the Y values together. That's it. All right. So A plus B equal bringing them together, 5 plus 7, 4 plus, just be careful with the signs, 4 plus negative 2. All right, I'm flossed out of space below that, so I'm just going to move to the side. So you get a bracket, 5 plus 7 should be 12, and 4 plus negative 2, before take away 2 will just give us 2. Now if we look at our illustration, does that make sense? That my start point way over here, all right, the start point to my end point, visually does that make sense? Well, we're going along 5 for A, and then we're going along an R7 for B. So from start to finish, must be 12 sort of units, 12 spaces along. We're going up vertically 4 units for A, and then we're coming back down on R2 units for B. So again, we are overall going up, all right, but just up 2. So it makes sense. So in component form, A, vector A plus vector B equals 12 over 2. That describes the shortest route from start to finish. Scalar is just a whole number, okay? So addition and multiplication of vectors by a scalar, okay? So V all we're doing in that case, 4V is just 4 multiplied by that component, all right? So we'd write it as 4 times, no, it is, it's just 4 times 4, and 4 times -3. Okay, we've got addition and a multiplication sort of spinning in here. Okay, so that would give us V, which is 4 minus 3, plus W, which is -5. Multiplying those terms in there. And 2, get that. And then you're bringing those terms together. 4 minus 10 would be -6. -3 plus 15 would be +15. Expressing that in component form would be -615. Looking at it like that, it's really basic. What that's describing is just a journey from start to finish. Two times 4 minus 3 plus 3 times -5 minus 9. Oh, -5, 9. All right, just the same process. So 8 minus 6 plus -15, 27 minus 20. Bring them all together. 8 plus -15 minus 20 minus 6 plus 27 minus 8. So minus 35 plus 8 is minus 27. That's not true. Oh, yeah, that's true. All right, so vectors in component form is really basic if you just know what you're looking at. It looks a lot worse than it actually is. Magnitude of a vector. Magnitude just means length. All right. The magnitude of a vector is denoted with two vertical lines in the vector letter in the middle. All right. The magnitude of, start a wee bit to the left. Yeah, so it's an A in between two vertical lines. All right, magnitude of vector AB would be denoted with the AB in between two vertical lines. All right, so it's essentially just boxing it off. At A vector component form 12 and 5. Okay. Visually, what that would look like would be positive on the x-axis and positive on the y-axis. All right, so we're going along 12, no, 5. Now you might be able to see very quickly that creates a wee right angle. Okay, so finding out the magnitude. Find the magnitude. You use the formula as Pythagoras. All right, you write it. So the length, that might have units, that might have centimeters as units. All right, so it's moved 13 units from A to B. All right. It's been described in component form as movement along the x-axis by 12 and up in the y-axis by 5, but the magnitude overall is 13. All right, so just if you wanted a wee note, wee reminder. It's explained in component form. Magnitude A. Essentially, you're just doing Pythagoras. All right. So you could get asked straight up, what's the magnitude of component of vector? All right, what's the magnitude of the vector? All right. More likely, you'll get maybe a couple to add together. All right. First thing you want to do is find the actual that in component form. All right, so in component form, so 9, 5. Okay, that is then what you're using in your x squared and y squared. All right. But then your calculator should get 6.14. All right. Separate the question from answer. Okay, we got it up. Okay, so if you get asked that when you're adding two vectors together, okay, you find the sum of them first, and then you find the magnitude. So you put it in component form first, and then you find the magnitude of it. All right, I'm going to quite a fast pace tonight just to get it done tonight. All right, there are questions that in your booklets that maybe break it down more step by step. Okay, so I'm making probably bigger jumps without allowing you to actually practice these. Okay, so just make sure you go back and you look at your booklet and just go through the questions, okay? Working out distance between coordinates. In 2D. In 2 dimensions. Okay. Coordinate we're used to being described to as XY. That's what we might coordinate. We can express that coordinate as a vector, okay, by putting it in component form. So that's just a coordinate in space. We can express that as a vector by putting it into component form that shows the distance from its origin to where it's finally ending up. Okay, so that could be described in component form as XY. All right, seems nice and simple. Okay, so a coordinate can be described in a vector form. Vector's just showing how far it's travelled along the X and how far it's travelled up the Y. Okay. Using it to calculate the distance between 2 points. Well, firstly we need 2 points. Okay, so we've got 2 coordinates, space, so we've got coordinate A, Z, Y, coordinate B somewhere else, which is also X, Y. We can create a path between them. So point A from the origin is described by X, Y. Point B is the same. From the origin to B, can be explained by my XY, or described when that in component form, XY. Now my vector path the distance between A and B, I would write like that. Okay, because now I am explaining it as a start point, and I'm explaining it with an end point. Okay, so my start point to my end point is A to B. Now, going back to that example where I went from Glasgow to Edinburgh, okay, I never went straight there. I followed a path. I went up to Stirling, I went up to Perth, down to Falkirk, and then ended up in Edinburgh. Think about that when we're going from A to B. because we have explained to us vector A from our origin, but also vector B. Now, we don't have enough information to just go directly A to B. We want to understand that distance. Okay, we write that as the distance from point A back to the origin. All right. Now, this is where direction becomes important. Get back to the origin, I'm going against the path. So I'm actually doing a negative A. And then from the origin to get to B, I'm going with the direction of that. Okay, so I'm going with the direction of that, so I'm positive B. I can rewrite that just to make it a bit neater. It's the exact same thing, but it's positive B minus A, right? Just keep that a wee bit neater. They like it, they prefer writing it like that. But that just describes the path that is followed with the information that we've got. So to get from A to B, my start point's A and my finish point's B. My path is going back against the direction of vector A and with the direction of vector B, okay? Follow coordinates. Okay, and you get asked to find the distance between the two coordinates. All right, so it doesn't even have to draw them out. We'll just separate the question off. Okay, so that'd be a typical question. Your answer A to B, B or B minus your A. Now B is asking for the coordinate B in component form. All right, so coordinate B in component form is just your X and Y put in a column. Your vector A in component form, just minus 3, 4. Okay, so when we're bringing it together, AB won't write a divide sign, my God. So vector AB, all right, from coordinate A to coordinate B can be described in component form as 7 along the x-axis and 8 up the y-axis. The magnitude of that, so the distance between the two coordinates, just by that. So again, it's nothing difficult per se. Just put it in. Right. Coordinate C minus 1210. Coordinate D (314). Find distance. Same process. Vector C can be described in component form -1210. Vector D can be described in component form 314. Vector CD, pathway would be your finish point minus your start point. Okay, and this time the letters just changed, but don't worry too much about that. Okay, it's just your secondary point minus your first point. So I'm going to ask you just to look at your booklet, all right, or oh, don't like colours. All right, so let's look at your booklet. All right, so we're working with 2D vectors starting on page 28. All right.
Sorry, what was the final answer for that question?
15.52.
Oh.
That's a lot of question, though. vector journeys. Question. One do you want to draw? State the result. Why those questions? All right, again, if you've got the booklet, it might be better just to open them and start where you feel comfortable. I'll put them up there. I'll freeze my screen. All right, that wouldn't work. Yeah, have a wee bash at that. All right, just to help you along. The vector A described by 3 places along the x-axis, -2 on the y-axis. All right, the arrow there. B goes along the x-axis by 1, 2, 3, 4. Positive up the y-axis by 2. And C visually you're going along the x-axis again positively and down the y-axis by negative. All right. So have a wee bash at that and then take a wee break. All right, we'll come back together at past. And then we'll go into 3D. Do the recording. Okay, so vectors are used, said at the start, when we're describing movement in 3D. Okay, so we need then to be able to illustrate in 3D form. So we're used to 2D form, where we've got X and Y, vertical and horizontal. Our 3D throws in another axis, which we refer to as our Z-axis. Okay, now let me draw a shape on that or find a point on that. Coordinates in 3D will be the form of, so I'll do coordinate A will be X, Y, Z. How far along X? How far along Y? And then this new one, how far along Z? Okay, so if I said point A is equal to 3, 4, 7. I'm going to my x-axis going along 3. I'm going to my y-axis, and I'm going up vertically by 4. And I'm going to my z-axis, and I'm going back the way with a depth of 7. All right. So it's like a point in space, and it's really sometimes quite difficult to visualize. All right. Don't know why I drew it 7, but not. But you can see the sort of wee pathway. Okay, so the 3 we're going horizontal, the vertical we're going up the y-axis, and then the 7 I'm going backward back into the page. Okay, there's a depth there. Okay, so it's a negative. If it's a negative, I'm coming towards the page, but if the positive, we're going back the way into the page. Frustratingly, we sometimes split the X, the Z and Y, all right? Not in the coordinate, but just the way they draw it. All right, so just be aware that the coordinates that we've been saying are X and Y the whole time. But round a wee bit, so Z would be a vertical, but you still write the coordinate in X, Y, Z. All right, the coordinate will always be written X, Y, Z. Okay. But it might show the coordinate with the Z being vertical, the Y being the depth. Okay, and the X is always the horizontal.
So see the question for this, but you get the coordinates and you need to trace them.
No. What they'll usually do is give you a 3D shape. Okay, so let me draw a 3D shape. Just as I can. All right, everyone sort of see that's like a cuboid. All right, so we've got corners. Got one of the corners in the origin. One of the corners here. So all those blue points are the corners of my cuboid. So you're looking at a 3D shape there. Right. So when I say cube, or that cube, has sides of 8 centimeters. What are the coordinates of the corners we need to label the corners? All right, so we're going to name the corner. A, B, and C are the bottom face. D, E, F, and G is the top. All right, so the bottom face is from the origin to A, up to B, along to C, okay, that's the bottom face. The top face of that cube is D, E, F, G. Okay. So I'm going to label all the corners knowing that all my sides are 8 centimeters. So my origin, 0, 0, 0. I'm at 0 on the x-axis, 0 on the y-axis, and 0 on the z-axis. To get to corner A, I'm travelling along the x-axis by 8. I'm not going any depth back, and I'm not going any height. So it's 8, 0, 0. B, slightly more complex. B, I've gone along 8 on the x-axis, but I'm also going to depth. Now that axis is the y-axis, my depth is the y-axis, but I've not got any height, so I've not got anything on the z-axis. And then C, I've not travelled along the x-axis at all. I've just gone back on the y-axis by 8, and I'm not going at any height. Now that's the bottom face. So that's the 4 coordinates of my bottom face. So all my z coordinates there, because I've not got any height yet, it's the flat face at the bottom of that cube. All my z-axis coordinates are 0. Now I'm going to introduce the height. Okay, so E is the one above A. Okay, so I'm in A on the X. I've not got any depth back, which is my Y. So I'm 0 on the Y, and I'm 8 on the Z. F is my biggie. I've gone back 8 on the X, or 8 on the Y, and 8 on the Z. If you can visualize that coordinate F, then it's half the battle. All right, I've gone along the x-axis by 8, I've gone along the y-axis by 8, and I've gone up the z-axis by 8. So that coordinate in 3D space is coordinate 8, 8, 8. G. I missed out D. X 0, Y 8, Z 8, and then D, which I've missed, is X 0, Y 0, Z 8. Okay. I'm going to snip that and copy that. You might get given word. So you might get said F. So this is a separate question. Okay, so this is a separate question. All right, instead of redrawing that cube, I'm just using it again. All right, so I've copy and pasted it. So it's a separate question. None of those last coordinates matter. Okay, so you might get given F as coordinate 5, 3, 4. And you could get asked the question, what is coordinate C? So you need to find coordinate F. Coordinate F is 5, 3, 4. So I'm along the x-axis 5, I'm back on the y-axis 3, and I'm vertical up 4. Then you find the coordinate C. What coordinate is that representing? It's representing that back left corner. So what information do I have just by that axis, all right? So just C sits on that y-axis. So I've not travelled along x any. So my x coordinate is 0. My y coordinate is my depth, it's how far I've gone back. Now C sits in the same face as F. So if F has gone 3 back, then my C must have gone 3 back. And my C sits in the bottom face of that cube, so I'm not going up any Z. So I'm using details from the image, but I'm also using details from the coordinate we get given to understand where C sits relative to each of them. Like, if I say what's coordinate B, that's sitting on the front face. Okay, so I've not gone back any on the Y, and it's sitting at the extreme left of my cube, so I've not got any in the X. The only information I'm missing is how far up in the Z axis am I. I can take that from my coordinate of F. So F I've gone up on the Z axis by 4. D is in the same face as F. So it must have gone up by 4 as well. Coordinate B. Coordinate B is right underneath F. It's on the bottom face, so on the Z I've gone no distance. Bottom face Z is 0. But B along the x-axis must have gone the same distance as F. So that's 5. And on the y-axis it's gone the same distance back, it's right underneath. Okay, so if you can visualize that, if you can understand what I've done there, it's half the battle. Because using these coordinates as vector points, it's the same as 2D. I just want to do one more 3D shape, just so you have it, all right? And that's again using the XYZs. But I want to show you that Z again. Z, that's Y, that's X. All right, this time I'm going to start my cube coming out from the origin, but coming towards me in the y-axis. Still going up the z-axis, coming towards me, So that's you. All right, so got a cuboid. Okay, and similarly speaking, that's point F. My coordinate for F, okay, is negative on the x-axis. So let's say -5. It's positive in the, positive in the z, but it's negative because it's coming towards me in the y. So say -7 and +8. Okay. Same on the z-axis. Okay. It's the same on the x-axis. But on the y-axis, I'm at 0. E, again, on the y-axis, I'm in the same as F. So I'm -7 on the y-axis. On the x-axis, I'm 0. And on the z-axis, I'm 0. Okay, so we're negative in a couple of different axes there. All right, so slightly different to those first two. Vectors in 3D, we treat the same way. Okay, now the vectors in 3D are going to allow me to work out the distance, the quickest distance from 2 points in a 3D shape. So vector FE would allow me to work out the distance from F to E. Distance EG would allow me to work out the distance from E to G. All right, so we're starting to think in 3D about distances. All right, how to get from one place to another. All the rules are the same. Okay, so if a vector was described in component form, it would just be a vertical column, x, y, z, and the magnitude quite neatly, z squared plus y squared plus z squared. So literally nothing different. All right. Remember, V is just a random letter with a sign to it. 4 minus 2, 8 describes what vector V is doing. Going along the x-axis by 4, down the y-axis by 2, and along the z-axis by 8. W okay. Vector addition. We've added 2 vectors together. Okay, so nothing changes in our rules. We'll just add an R term in.
Did you just make those numbers up there, or did you read them off that graph you drew before?
No, I made them up.
Okay, cool.
Completely made up. Okay, so nothing's changing now. Now, if I take that 4V plus 2W1, if I take that one step further and that's to find the magnitude of that,
Sorry, could you go back to that page again for me?
of course.
Thanks. That's fine. Thanks.
Okay, that's me worked out the distance between 2 points, essentially, 2 vectors. So if I put that into an image such as that, okay, and I've got my 3D coordinates. Okay. My coordinate for E coordinate 5, 0, 4. And my coordinate for C is 0, 3, 0. All right. Coordinate E is in the top face of the cube. So I've got some distance in the X, in Z. It's in the outer edge of the cube, it's to the outer right hand side. So I've gone along the X, so that's where my 5 and my 4 come from there. My C value is the bottom face of the cube. It's the bottom left hand corner, so I've not got any distance on the X axis or the Z axis. But on the Y axis, I've gone back 3 spaces. I want to know the distance between C and E. Now remember, I can describe each of those coordinates as a distance away from the origin. All right, that's essentially what I'm saying there. So my pathway, like we did in the 2D shape, can be described as well. Okay, that's maybe quite difficult to draw yourself, but essentially what I'm saying is from my origin to E, okay, I've travelled along my x-axis 5, I've gone up my z-axis by 4, but I've not done anything in the y-axis. Okay, so I've described that journey. Likewise, my coordinate coordinate C, described as such. So to get from E to C, I'm going to follow a path again. I'm going to start at E, I'm going to go back down the green line, so I'm going to go against the grain, all right, back to my origin, and then from my origin, I'm going to go up to C. So that's the path that I'm following. All right, so similar to when we described that path in the 2D, I can follow vector E back the way. Oh, sorry, C. So I'm following C back the way to the origin and then out to E. All right, C is my start point. All right, so I'm going against the grain back from C to the origin and then out to E. All right, so my start point C. So that's the same as what we did in the 2D. Okay, but we've now just got more terms. So C to E, well, my E put into quotient form, it's just that. C component form of that. It's just 5 minus 0. Zero minus 3 and 4 minus 0. I'm going to get 5 minus 3, 4. That describes the journey from point C to E.
Is that the magnitude?
No, that's the vector to go from C. That describes the journey from C to E. All right, so that's the direct route. Okay, that is my pathway. That's my long route. Oh, okay. But I know I can describe that pathway because I've got this information. So that information, those coordinates describe the route from the origin to that point in space. But to connect 2 points in space, I need to figure out the direct route. So that direct route bypasses all the other point, and it just connects the 2 points there. The bottom left-hand corner and the top right-hand corner just connects them directly. So to get from C to E the quickest way, I just travel along X5. Okay, I come back in myself along the y-axis by 3, and I'd have to go up the z-axis by 4. All right, and that's the most direct route. The coordinates describe the point in space. The component for down here describes the route from 2 points in space, the quickest route. All right. That's the route from origin to point in space. My magnitude would be denoted like so, and it would just be x squared plus y squared plus x squared. And that's my magnitude. Right? Don't necessarily need to be given the image. All right, so finding distance between 2 points. Okay, and you get given the coordinates x5. Alright. You have to create the path, alright, so if we're creating the path A to B. And the magnitude AB. I know I'm pushing it. There's a couple more things we need to cover, alright? And then we're done with all the learning ever. Alright, and this is a type of question that they ask. Alright, so that type of question there is a common one, alright? They'll ask you about a 3D shape, about coordinates in 3D. Alright. Another way they could ask you is going back to this vector pathways. Alright, so similar to what I just showed you in regards to getting from point to point, so from E to F, or whatever it was, E to C. We had to follow a path of known vectors. Okay, so we didn't, having just two coordinates in space didn't allow us to do anything, but it allowed us to follow as a path of a known route. All right, and then that allowed us to find the shortest distance A to B. Now, if I've got a shape, if I've got a square, cuboid, all right, if I've got a cuboid, or a square even, a vector in that form, okay, describes a route taken. Doesn't but to explain this the best way. I'm trying to jump ahead a wee bit just to get it over. Alright. It describes a route taken, alright, so that the three terms on it, three parts of its component, can be used at different length, at different lines, as long as they're the same. Okay, so U, the vector U could be used to describe that top line there. The vector U could also be used to describe that bottom line there, because they're mathematically the same. So it doesn't necessarily matter at what point in space, when it's denoted in that format, where the actual vector is. Okay. So because the left and right hand side of that as well are the same, we can call them the same. All right, apply a direction to it as well. Now that's important when we're considering vector pathways. Oh, certainly that's the way they ask the question. All right, so we can call two different lines by the same vector. Example of a pathway, okay. The diagram shows a trapezium. A trapezium is just a four-sided shape of random lengths. Trapezium. I hate these questions, by the way. Okay. Also, as part of the question, it gives us the notion that vector AB can be noted as U, and vector BC can be denoted as V. Okay, so that's the question you're presented with. The diagram shows a trapezium with side DC equal to 2 times side AB. Okay, and you've got that shape down the bottom, and you've got letters A, B, C, and D. Okay, and you can sort of see a pathway between A and B and C and D. Expressed in terms of U and V. Vector DC. Now you get told in the question that DC is equal to 2 times AB. So vector AB when we denote it with those letters, connects point A to point B. But when we denote it just with the U and underline, just as a small letter there, just by a single letter, that denotes the route that that vector takes. So it doesn't note 2 points that it's connecting, but it notes the direction of where it's going. So I can apply that same vector route, but to another part of this shape. So DC being 2 times AB means DC is equal to U. Vector AC. Now vector AC is looking for that pathway that goes from A to C. Okay, now we've got the vector AB described as U and BC, and the question is described as V. So to get from A to C, we need to go along vector U and go along vector V. They're both going in the same direction. Okay, so it's U plus V. Pathway to represent AD. Okay, well, AB is represented by U, BC is represented by V, DC we're represented by 2U. Okay, and the direction is D to C. Okay, so that follows same route as sort of U, but it's twice the length. So we need to describe AD in terms of U and V and what we've got, using the directions we're also presented with. Now we do not have the information that tells us what this is. We do have the information to follow a pathway that starts at A and goes to B, so that's U. We're adding on B to C, which is B. Then to get to from C to D, we're going against the grain. We're going against the direction that 2U is going. So that means we're going in a negative path. And it becomes negative 2U. Now I'm going to create another point on this. And I'm going to create a point M. M is going to be the midpoint. Okay, so for D of this, M is a new point. Midpoint between C, B and C. So if I was to describe BM in terms of U and V, traveling from my known point B to get to V, to M, I'm going half the distance on my vector V. So it would be half V. One last one on this, D to M, my pathway would start at D. I'm traveling in the correct direction along the 2U, so it's positive 2U. To get to M, I'm going from C to M. I'm going against the grain of V. So it's minus half V. There's a lot going on in that. These questions tie you up in that. That is vector pathway, and it's a type of question that they could ask.
Is that like a past paper question then, that kind of thing?
Yeah.
Okay.
So they would only, so they wouldn't necessarily run it through like that, ask you DC, AC, AD. They would just jump straight to DM.
Right.
So they would
And
give
then you would need to work out all that bit in the middle.
yeah. So you'd essentially, you'd need to sketch on the U, and then the 2U up the top and the V, and then you would work out everything in between.
What's the likelihood of this coming up in the prelim? Hmm?
Aye.
You're kidding. Is it? Oh, for God's sake.
Would be like
Absolutely no the end, but no.
all you're doing is following a path.
No, but that.
See what's really bonkers about it? It looks like so much is going on there. But genuinely, all you're doing is walking a path from, so D to M, for instance, all you're doing is starting with D, walking along to C, and then back down to M. But it's the way you're writing that out is the complex part. All right? So it's, you sometimes overthink these questions because in essence, it's theory behind it's not difficult. So your mind plays tricks on you. And think it can't be as simple for 3 marks to just do 2U minus a half V. But understanding the concepts behind it, it explains the journey from D to M. Just going back to our Glasgow to Edinburgh, I think it's just jumping up to Stirling, to Perth, to Falkirk, to Edinburgh, instead of going in a straight line. That explains the most direct route. Which is that. I don't have enough information to tell me that, so I need to follow the path. So does anyone want to do HNC engineering? No? No, cool, don't think so. Let's call it this. See you on Tuesday. I'm going to send out a practice prelim with solutions. It will tell you the level